Hello everyone, this is Mrinal Kanti Roy Chaudhary. The title of the talk is An Open Problem on the Quantization for Uniform Distributions on Stressed Sierpinski Triangles. Consider a set of three contractive similarity mappings, S1, S2, and S3 on R square, such that S1, S2, and S3 are given as follows. S1, x1, x2 equal to 1/3 x1, x2, S2 of x1, x2 equal to 1/3 x1, x2 plus 2/3 of 1, 0, and S3 of x1, x2 equal to 1/3 x1, x2 plus 2/3 of half, root 3 over 2 for all x, x1, x2 belongs to R square. The limit set S of the iterated function system, this is a version of the Sierpinski triangle which is constructed as follows. Start with an equilateral triangle. Delete the open middle third from each side of the triangle and join the endpoints of the adjacent sides to construct three smaller congruent equilateral triangles. Repeat step 2 with each of the remaining smaller triangles. At each step, the new triangles appear as radiated from the center of the triangle in the previous step towards the vertices. In order to distinguish it from the classical Sierpinski triangle, we will call it the stressed Sierpinski triangle. So here it is constructed. To get the stressed Sierpinski triangle at the zeroth level, we consider the equilateral triangle with vertices 0, 0, 1, 0, and half, root 3 over 2. So this is an equilateral triangle with these three vertices. So if you apply the mapping S1 on the whole triangle, it goes to this small triangle. Then when you apply over this triangle the mapping S2, then it goes to this small triangle. Then when you apply S3, it goes to here. Now if you apply again the mappings, then you will get the small triangles. And if you keep going like this way, in the limit, you will get the Sierpinski, stressed Sierpinski triangle. It is easy to see that the area and the circumference of a stressed Sierpinski triangle are 0, and it has Hausdorff dimension 1. Let P equal to this. Then P is a unique Borel probability measure on R square which support the stressed Sierpinski triangle generated by the three mappings S1, S2, and S3. For this probability measure P, Comage and Roy Chaudhary gave an exact formula to determine the optimal sets of n means and the nth quantization errors for all positive integers n. They further showed that although the quantization dimension exists, the quantization coefficient for the probability measure P does not exist. So here is their paper, Quantization for Uniform Distributions on Stressed Sierpinski Triangles. It was published in 2019. Now let me show you how they got their answers. They have proved that, remember here, the stressed Sierpinski triangle, it is like the mappings are also homogeneous. That means the similarity ratios are same, and also P is a uniform distribution because P of the whole triangle is 1, P of this part is 1/3, P of this small triangle is 1/3, P of probability of this small triangle is 1/3. So you can easily guess optimal set of 1 mean will be the center of the triangle, and optimal set of 2 means are these 2 points. So if you look, these 2 points also you can choose one from here and one from here, or one from here, one from this side, because of the symmetry. So thus we understand optimal sets of 2 means, an optimal set of 2 means is not unique. There are 3 different optimal sets of 2 means with the same quantization error. Now, optimal set of 3 means are these: center of this, the centroid of this triangle, centroid of this triangle, centroid of this triangle. Now, optimal set of 1, 2, 3, 4. 4 means look like this way. Of course, there are several, because by symmetry you can move this to here and you can move this here. And so these are the configuration of optimal sets of n means for n equal to 1 to up to 8. 1, 2, 3, 4, 5, 6, 7, 8. If beta is the Hausdorff dimension of the stressed Sierpinski triangle, then by the standard formula, we get beta equal to 1. Moreover, if P is the self-similar measure generated by the similarity mappings this associated with the probability vector this, then we know from this paper by Moran and Ray, geometry of self-similar measures, they showed that if P is the self-similar measure generated by the similarity mappings this associated with the probability vector this, then Hausdorff dimension of the measure and the packing dimension of the measure is equal to this one. So Pi log Pi, sum of all of the Pi log Ri. And Ri are the similarity ratios of the similarity mappings Sj. Using this formula, we see that the Hausdorff dimension, packing dimension of the probability measure P, this P, supported by the stressed Sierpinski triangle, are also obtained as 1. Quantization dimension of the probability measure is also 1 that we have shown in our paper. Quantization for uniform distributions on stressed Sierpinski triangles. So we saw Hausdorff dimension of the stressed Sierpinski triangle is 1. Then Hausdorff dimension of the measure, packing dimension of the measure is 1 because of this formula. And we found quantization dimension is 1. So all these 4 dimensions for stressed Sierpinski triangles coincide. And quantization coefficient does not exist. Now there is an open problem. Here it is. Notice that a generally stressed Sierpinski triangle can be constructed by the similarity mappings S1, S2, S3 on R square in many different ways. See that S1 extends to R, S2 extends to R of this, and S3 extends to R of x1, x2 plus or minus R. And our work, that is the work of Gomez and Roy Choudhury, was done for R equal to 1/3, the exact formula they gave. It is still not, look here, R lies between 0 to 1/2. So the work of Gomez and Roy Choudhury is for R equal to 1/3 only. It is still not known what is the least upper bound of R, for which the exact formula to determine the optimal sets of n means and the nth quantization errors given by Gomez and Roy Choudhury works for the uniform distribution P given by this, which has support the straight Sierpinski triangle generated by S1, S2, S3. This is an interesting open problem. Again, the paper of Gomez and Roy Choudhury is this quantization to know more details about this construction. The name of the paper is Quantization for Uniform Distributions on Stretched Sierpinski Triangles. And this was published in 2019. Thank you for listening.